Let's take a look at solving these quadratics by extracting square roots. The extracting square roots, we're looking at getting the x squared or the y squared or m squared or whatever the squared is by itself. In part A, it's already by itself, so I'm going to get rid of the squared by taking the square root. I'm going to extract the square root. So I've got x is equal to the square root of 56. Whenever I take the square root, I get a plus and a minus. So I end up with a plus and minus the square root of 56. I'm not done yet. If you circled your answer and finished there, I would give you half credit on a test, but it is not a correct answer. The correct answer is that underneath that square root, I've actually got a 4 times 14. Where did I get 4 times 14? Well, I looked at 56 and I wanted to see what perfect squares are underneath there, or what perfect squares are in 56. If you were in my class last year, you looked at breaking down 56 like this. A lot of us know that 56 is 8 times 7. This is 4 times 2. The 4 is 2 times 2. We have a pair of 2's. And then the 2 times 7, which is the 14. The pair of 2's get to come out of this square root. The pair of 2's come out. That is the square root of 4. The square root of 4 comes out. So the perfect square that's in there gets to come out of the square root. And whatever's left inside does not get to come out. The 7 times 2 is the 14, and so that has to stay in. There are no other perfect squares in there. That is going to give us the correct answer. In part B, you get the x squared by itself. So I have to divide by 3 first. I'm going to take a square root. So I get x equals, when I take the square root, I get a plus and a minus. 6, if I'm going to break down 6, I only get 3 times 2. There are no perfect squares in there. And so I end up with plus and minus the square root of 6. There's no breaking down that needs to happen for that. We will talk a little bit farther about breaking down square roots as we continue, but this is the first place that you should start remembering that extracting square roots idea. On the next page, part C, again, we want to get that square root by itself, so I'm going to divide this whole thing by 2, and I get x minus 5, quantity squared. 72 divided by 2 is 36. Now the square root actually is by itself. It's got some x minus 5 stuff inside the parentheses, but the square root is the next thing that we need to get rid of. And so I get rid of the square root by taking, or the squared by taking a square root. So I get x minus 5 equals plus and minus. The square root of 36, well, that actually comes out to be a nice number. The square root of 36 is 6. And then I want the x by itself, because that's the whole goal. So I add 5 to both sides and add 5 to both sides. This actually gives me 2 problems. It gives me x equals 5 plus 6, and it gives me x equals 5 minus 6. The plus and minus actually creates 2 different problems. Well, 5 plus 6 is 11. 5 minus 6 is negative 1. I end up with x is equal to 11 and x is equal to negative 1. When we start getting into pluses and minuses, you want to make sure that you throw these numbers back in and check them. Plug an 11 in. 11 minus 5 is 6. 6 squared is 36 times 2 gives me 72. Plug in a negative 1. Negative 1 minus 5 is negative 6. Negative 6 squared is negative 6 times negative 6. That's also 36 times 2, 72. Okay, so both of those work. And the last one with extracting square roots, I want to get the x squared by itself. None of this information is inside the parentheses, so this is like solving a regular equation. If I didn't have that squared there, I know that all of you would add 4 to both sides and divide by 5. So that you would get the x by itself. You just have that one extra step. Now that I have an x squared, I have to get rid of the squared. So I take a square root. And when I do the square root of 14, well, 14 breaks down into 7 times 2. There's no perfect squares. There's no perfect squares for the square root of 5. But that takes us to the idea of having a square root in the denominator. And so when I take this problem, I get x is equal to plus and minus, because I took the square root, the square root of 14 over the square root of 5. You did a lot of work last year with rationalizing the denominator. And if you were to answer this problem with either the square root of 14 over 5 or the square root of 14 over the square root of 5, I would give you half credit on that. The correct answer goes a little bit farther than that, though. Goes a little bit farther because I can't have this square root in the bottom, so I need to multiply by the square root of 5 in order to get rid of the square root of 5 in the bottom. And I use the square root of 5 because the square root of 5 times the square root of 5 is the square root of 25. So I end up with the square root of 25 on the bottom, and the square root of 14 times the square root of 5 is the square root of 70. The square root of 25 comes out to be a nice number, so I get plus and minus the square root of 70 over 5. Do not reduce the 70 with the 5. 70 is underneath the square root, and the 5 is not. Those do not reduce. So that ends up giving us the correct answer for that one.